2 is a day, Jesus made.
It's voting day.
Better.
What?
It's triple integral day.
Oh.
Triple integrals. The last thing we do before the exam.
Wait, where's everyone else?
Just as with double integrals, we define it just over a box. And again, it is a triple Riemann sum, just like double integrals are a double Riemann sum. We're not going to be using this definition at all. This is just to show you what a triple integral actually is. Again, this is actually a layman's definition, so to speak. The actual definition would be worse. So we're just going to move on to my favorite theorem. Fubini's theorem now for triple integrals. So what do we have? We've had Fubini's theorem, the weak form. Then we had the actual form. Then the form for polar. Now we have triple. There are 2 more forms. We look at that after the exam. In fact, if f of x, y, z is continuous on a rectangular box, AB cross CD cross EF, then the triple integral over that box of f of x, y, z dv, notice, it is now a volume differential that we're working with. It's an iterated integral. Integral e to f, integral c to d, integral a to b of f of x, y, z, dx, dy, dz, or any of the other 5 possible orderings. And there are 6 total ways you would order dx, dy, dz. Typically, it's dz, dy, dx. It's kind of like the default order. But order does not matter.
Is the typical order because the z tends to have the most variables in it?
Yes, it's usually written as z equals 100, or no, no, it's just that's
Just convention.
Because in a box form, you would have
That's
in that order dz, dy, dx would be a to b on the outside,
Yeah,
right? Then c to d, then e to f, so it'd be kept in that order.
yeah.
And also, a lot of time, it's easier to write the height, where we get the general region, and we'll get to. Generally easier to find bounds for the height in terms of x and y than it would be to say find bounds for x in terms of y and z. Generally speaking. So over a general region, let's say your region, I stuck with the MatCal-E, that's what the text uses. Typically I use a W, but again, it's just a set of ordered triples x, y, z, such that the ordered pair x, y is in a domain D, and z is bounded by 2 functions of x and y. Obviously, this region E is a subset of R3, which is real space. D is your projection of E onto the XY plane. You can think of it like a shadow. So it's the shadow of the three-dimensional region on the XY plane. Then the triple integral over E of f dv is an iterated integral. It's the double integral over your region D of the integral from u1 to u2 of f, then dz dA. And again, there's no rule that says that it's Z that has the bounds for and that your D is in the XY plane. You can also have D in the YZ plane or the XZ plane. And then just make the changes accordingly. It's just whatever's the most convenient. And so this is somewhat pictorially your E and your D. So keep in mind we're now evaluating integrals over solids. It's now a three-dimensional domain. So double integral is over an entire two-dimensional region, essentially an area. Triple integral is over a solid, so again, essentially a volume. I wonder if there's an integral that would just be for the boundary. And I wonder if there's an integral that would be just for the surface, not the volume.
Did you check Davy Jones' locker? It's probably in there.
Don't need to. Spoiler alert, there are. We'll be looking at. That would be on. Average value, same kind of idea as with double integrals. Average value of the function over a solid E is just 1 divided by the volume of the solid times the triple integral over the solid of f dv. Oh, volume of E. What do you think that is?
So it's a triple integral of 1?
Yep.
Okay.
Triple integral over E dv. Just like area was a double integral dA. So now we don't have to worry about double integrals for volumes. We can now just use a triple integral to find volume, unless you're told to use a double integral. And again, we'll start off simple and work our way up in difficult. So start with iterated. So the bounds are already set up for us. These are the boring problems. It's going to work the same way as with double. You start with your innermost first, and then work your way out. So in this case, we start with the integral with respect to z. Antiderivative of x, y, z with respect to z.
I wrote it as x, y, z squared over 2.
That. Go back to my convention. Let's see how lucky we get. I'm not going to expand that out just yet. Now we integrate with respect to y. What is that antiderivative with respect to y?
Y squared over 2 times x times, in parentheses, 2 minus x squared.
Well, plumber. He calls me to go and so you get to do it.
Wait, what? No. Hold on, I have to write it out first, then tell you.
I tried to stop myself from yawning, but
That's what I call.
it is, you're going to, and then it calls me to have to yawn.
Hey, you looked at me.
Didn't have to, I heard it. All that time loop discussion. Now we need that antiderivative. Actually, because it's 0 to 1, it's kind of easy to evaluate. First term, I'll just evaluate the 2. Then minus 4, plus 13 over 4, minus 6 over 5, plus 1 over 6. Two minus 4 is negative 2. That's not. What is the LCD? Thankfully, it is indeed 60. Now what's the numerator?
Negative 26.
That's what I got, 13. Let's just double check.
I also have 15.
13 of 60. So the result of that iterated integral is 13 over 240. Calculus is easy. It's really difficult.
You get too comfortable with the simple numbers. And 3,000 plus 32 and 3,034.
Arithmetic's hard.
Think about it, huh?
Counting is really hard. What are we starting with? Does it matter? No. We can start with whatever we want. As it's written, we start with Z. That's what we start with. What's the antiderivative? gonna have 2 on the outside, right? What would you have to integrate with respect to next? What is that antiderivative?
1/3 r cubed sine theta.
Oh, how nice is that? That just evaluates out to 1, r cubed, right? R cubed from 0 to 1 is just 1. That's nice. What is the antiderivative of sine theta?
Minus cosine theta.
What does that evaluate to?
Let's see.
Sorry.
2/3.
Good?
I think so.
Still in the shallow end. I am going to make life really easy. There's no thetas, right? What's the length of the interval 0 to pi? What is it? It's just pi. How'd you get 2 pi?
It's usually the answer when it comes to, the length of stuff. Safe choice.
Well, that's when we were doing polar. It was always 0 to 2 pi. That's why. This is just 0 to pi. There's no rho either. What's the length of 0 to secant phi?
Secant pi.
What's that? We just did 2/3 of the problem in like a minute. How are we going to evaluate that? I'll rephrase that because I know how I would do it. How would you evaluate that? True, but that's sine of 2 phi, not sine of phi. It'd be sine of 2 phi over cosine of phi, which doesn't help. Actually, it does, but
One equation, and one instead. Looking at two times the,
2 times what?
2 times the is the number of cosine. Like that one, and then. Because cosine reduces.
Right, but that's cosine squared.
Change sine 2 phi to 2 sine phi cos phi.
Double angle for sine. Sine of 2 phi is 2 sine phi cosine phi. What's secant times cosine?
1.
1. That's just sine. Oh, isn't that nice?
32 over 2.
Oh, I forgot something. Drop me two.
Go to 2 top. Watch it high. Just go to 2.
I missed the step up top where we went right to pi to 4 of phi. I just missed how we abbreviated that, how we did that.
You missed it.
I missed it. I was trying. Yeah. What's that?
Swing and a miss.
Yeah. Yeah, I was swinging.
How the Phillies played.
I was swinging my heart out, but I missed it. I couldn't. Right, but I mean from what we're given to that.
Oh, to that step.
Yeah.
Do you see a theta?
No, there's no theta.
What's the length of 0 to pi?
The length of 0 to pi.
What's the length of that interval?
That interval, pi?
Pi.
Okay.
That's where that pi came from.
Oh.
Do you see a phi? Do you see a row anywhere?
No.
What's the length 0 to secant phi?
Secant phi.
That's what the secant phi
Okay.
came from.
All right. I see. So since you would effectively just be putting them in there, and then I got you. Thank you.
Good. Now now it just goes right to 28 feet deep. And there's hungry sharks with laser beams attached to their heads. And there's no gradual decline. It's just, maybe I'll tie rocks to you as well. Hungry sharks with laser beams attached to their heads.
I like how we say first octant, even though there is no second or third octant. Like they're not-
There is, we just
Yeah.
don't specifically.
Yeah, the
But we do define the first octant.
Do we find the eighth octant too?
Yes. The first octant is the only one that we all agree is the octant where X, Y, and Z are all positive.
Why can't we just come together and agree with the other one?
It shouldn't be that hard.
You expect people to come together and agree on anything?
I mean, that seems to be what math's all about. People
We've
disagree.
never been to a math conference.
People disagree. They beat each other up, math, like with math, and then they figure out who's right, so they
Have
agree
you ever
afterwards.
been to like any group of scientists?
We never want to admit someone's right. We would die before we admit that someone is right. We're not nice people. Strong is even worse. We just have not agreed on a convention for the other 7 octants. That's right. Did you know that math used to work without 0?
I did do that.
That was recently, I believe, the 1800s, I think, is when they finally accepted 0. They ignored it.
What?
They just ignored it
I didn't realize it was that recent.
Yeah.
I thought it was,
fairly recently. Infinity is even more recent. The idea of infinity is even more recent. Before that, mathematicians just refused to accept it. And if you mentioned it, they threw you out the window. So let's try and get a visualization of this region. So we had the planes y equals 0 and z equals 0. We had the plane x plus y equals 2. The plane 2y plus x equals 6. Why is it 2? Why can't it do x equals 2? That's irritating. And the cylinder, y squared plus z squared is equal to 4. Right, we're told it's in the first octave. So all three are going to start at 0. How far out do we want to go? Let's go with 3. Would that work? Probably not. I'll go with 4. Now for all the options, I'm losing this one. And this how it looks. Let's try and rotate that. Again, to an advantageous kind of orientation. That's still not done with that. Well, kind of looks good. So what we're looking for is in the 4 planes, but under the cylinder.
So this little bit here all the way up to the center. That is our topology.
Before I lose this, let's save this. This is set of ordered triples such that well, z represents height, right? The height is very easy to find, isn't it? If you move around that region, what is the height?
Between 0 and 2.
Square root 4 minus 1 squared.
And it's the floor to the ceiling, which happens to be that cylinder. And no matter where you are, right, so if you imagine this is the room, no matter where you are in the room, it's a constant ceiling, right? That cylinder is the ceiling for the entire room. This is X. This is Y. So if you imagine, notice what's going to happen with Y as you move. You can have at least 2 triple integrals. Right, it's going to be from the green to the cylinder, and then from the green to the red. I don't think we ever have to worry about, well, you may actually have 3. You may have from this arm reach to the cylinder at some point. Right? It's kind of hard to see in this view if there's going to be any point where you get I think that's supposed to be yellow, right? Y equals 0 to the cylinder. I don't know if there's any point where that's going to be part of the region. Not the pain in the ass. But if we do X, isn't it always going to be between the green plane and, what color is that, red? The red plane? So wouldn't it be easier to describe X in terms of those 2 planes? So now the question is, what is the direction of increasing X? Well, it's coming out of this, right? 0, 1, 2, 3, 4. So lower bound will be the green, upper bound will be the red. You see that? What is the equation in terms of Y for the green plane? X equals what? And now the red, X equals what?
6 minus 2.
Now you need bounds for Y. Corner there. Y goes 0 to 2. Right. So because we started with Z, Z will have to be written in terms of X and Y. Then X is written only in terms of Y, and then Y has to be constant. It can't be in terms of any of the 2 variables. That was the toughest part, was describing the region so that we could set up vertical integral.
I understand why y can only be in terms of constants, but why don't we factor in like the red plane when it
For y?
counts for y?
Because at that point, it no longer, because the red plane was factored into x, so we've already accounted for it.
Okay.
Right, so you kind of have to look at it. What we did was, we got the height. Now we ignore the height. Now write it as two-dimensional.
Okay.
Remember what we did? You had a bar that slid. So we're essentially saying, okay, we're setting the bar to be y, which was horizontally simple. Remember we were doing double integrals?
Yeah.
That bar slides from 0 to 2. What does it extend from? The green to the red. That's what we did. I just didn't actually plot out the two dimensions, which I could have. So y equals 0, we ignore z. And so you just set z equals 0 because we're now looking at the shadow. Make you agree those would be the four curves?
Yeah.
We're in the first octave, our shadow's going to be in what quadrant?
1.
And I'll stick with the same bounds that I did for the three-dimensional. Actually, didn't go out far enough. That's going to go out further. No, let's go up 6. Perfect. That's too high. That's too high. This would be the two-dimensional projection, right here, this region in here.
Okay.
You see that?
I think so.
Define that horizontally simple.
Okay.
And so you draw the line, your bar. So in terms of sliding in the region, we're going to be sliding it up and down, right? What values does it slide along on the y-axis?
From 0 to 2.
Right, so that's why y goes 0 to 2, and then what does it go from as it's sliding in that region from 0 to 2? What does the bar extend from? This yellow line, which would have been the yellow plane, right?
Yeah.
Or whatever color plane it was, to the green line.
Okay.
You see that?
Yeah.
But that's why then y goes from 0 to 2, because that's how we defined it.
All right.
I could have done vertically simple, right? Had x go from 2 to 6.
Yeah.
But then the problem is we're going to have two separate. It's going to be the union of two regions, right? yellow to red, and then 0 to green.
It makes more sense when it's pictured like this.
Yeah, that's why.
Got it.
Yes.
So when you were defining each of these by either constants or formulas in terms of the other variables, it has to be for Z, it's got to be true everywhere, 3D. For X and Y, it has to be true on this.
Well, for Z,
Yeah.
you're looking at the height.
At the height.
Right, so
Yeah.
again, imagine you're in a room
Yes.
like this, and you extend a ladder up.
Yeah.
What is the ladder extending from? Starts from the floor, which is 0,
Right.
up to the ceiling, which in this case is that cylinder.
Yeah.
Now you've done Z.
That's it. Yeah.
Now you look at the shadow.
Mhm.
Look at the projection of that three-dimensional solid
Mhm.
onto the XY plane.
And on that shadow, what you come
That
up with
was this,
has to be true everywhere on that
right?
shadow.
So
Okay.
this bit here
Yeah. Yeah.
is the shadow of our three-dimensional region onto the
Yeah.
XY
And it's
plane.
always that.
And then it's now a double integral to find the
Right.
two-dimensional region.
Gotcha. Okay. Thank you. And that's why we saw it for X first instead of Y.
Because it would have been a union of two
Right.
sides.
Gotcha. Okay. Thank you.
Right, so that is what I did. I just did it from three-dimensional picture.
Okay.
But again, I've also been doing this for decades, so it's easy for me to see.
It's not really like much more easily comprehensible when you put it like that.
What?
Like with how
The projection?
Yeah, with the projection and the shadow thing. The shadow idea just totally blew it over.
You know, that's all the projection really is. It acts like a shadow. It's even cooler when you study advanced physics and you start thinking of three-dimensional objects as shadows of higher dimensional.
Shadows can have really good dimension.
Oh yeah. If you're a four-dimensional being, you're going to have a three-dimensional shadow.
Other dimensions totally like work everything.
Mm-hmm. Don't try and imagine it, because you can't.
Yeah, it doesn't work.
Look up a hypercube. What they show you is the three-dimensional shadow of the hypercube, because you can't actually visualize a hypercube.
Oh.
But that would be the three-dimensional shadow of the hypercube, is what they picture. And it looks like a cube in a cube. So we're not quite done the hard part yet. We've described the region, but now we have to translate it into a triple integral. All right, so this is what we're looking for. And the function was what, z, right? Now, based on how we described it, what's the order? So what are we going to integrate with respect to first? Then what? Then what? Could we do x and then z?
Yes, that's
Yeah, because z doesn't depend on x. So we can freely interchange the order of x and z without redefining the region. But y has to be last. Otherwise, we have to redefine it. Y went from 0 to 2. I'm going to stick with the dz, dx, dy. X, we said, went from 2 minus y to 6 minus 2y, and then z went from 0 to the square root of 4 minus y squared. That is the hard part. Now, it's just an iterative integral. So evaluate it. going to be z squared from 0 to root 4 minus y squared. That's just 4 minus y squared, isn't it? That's nice. Oh, there's no x, so that's easy to do. Six minus 2 is 4. Negative 2y minus negative y. So that's 4 minus y. We have to do algebra. At least this one's not too terrible to do. All right, real quick. Expand that out. What do you got?
16 minus 4y minus 4y squared plus 1 cubed.
You sure?
Yeah.
Excellent. And it didn't take you too long, so great job.
I haven't had a 4.
You're halfway out of the infinite put it in. And you start with infinite distance again. That's right, just keep dividing by half and you're never going to get out of it for this finite. Nope. And if I let you count half the distance for each correct answer, you're still never going to get out. That's actually a really interesting problem to do a thought experiment. You keep cutting distance by half, you ever reach your destination?
That's why a race car can never reach the finish line. Because it travels at a constant speed, for example, and in one time it gets halfway closer, and then in half the time it gets another halfway closer, and then just keeps getting halfway closer, and then can never reach it, right?
So that is a little bit different. Because because the race car is not being restricted in your example to only going half the distance of your mind. Half the remaining distance, because it's traveling at a speed. The thought experiment is, all right, so let's say from here to the door. In the first second, you're allowed to cover half the distance. Second 2, you're allowed to cover half the remaining distance. The next second, half the remaining distance. So you're only ever allowed to go half of the remaining distance each second. Then you have to let t go to infinity to actually reach the destination. For the race car, it's going at a certain rate. Right, and because it's going at a constant rate, specifically the amount of time it takes to cover half the remaining distance keeps decreasing. Specifically to 0. So in that case, t would go to 0. Or the time is approaching 0 with each half distance, so it will eventually get there.
Yeah, I guess.
It's really weird.
So a better paradox is you have a lamp. When you have 1 minute, when half the time is left, you either turn it on or you
Correct. You switch the destination, and you keep doing it in half intervals. Yeah, that would be the good. Is the lamp on or off at the end?
It's broken.
Because you keep dividing time interval in half, which means that goes on. Good thought experiments. That's the kind of stuff you do in philosophy and math. But that was enough time for you to evaluate that interval list, by the way.
116 over 6.
That is not what I got.
38 over 3.
That is not what I got.
52 over 6.
That's what I got, 52 over 6. But that's not simplified.
Of course. 20. 1 is 3 over 26/3.
26/3. So, last question.
I have a question.
Might have an answer.
And it might be kind of too early for wondering about this kind of thing, but like in that model, if the lines that the diagonal planes, if they tilted out, making the shadow bigger, would you? It'd be the same rules, right? You'd still be looking at the shadow, even though it goes beyond where where the planes intersect the XY, where the planes.
Well, it wouldn't go beyond where they intersect, right? If
Well,
they tilt out,
yeah,
all that's going to happen is now it gets
the shadow gets bigger.
right. You have to look further, but it's still going to be bounded in the first quadrant.
Right.
But it's still going to cross the x-axis at some point.
Right. But like the
It's a
fact,
diagonal line,
the
so
fact-
you have to cross the x-axis at some point.
right. But the fact that the shadow is now like beyond where those planes intersect z=0, that plane, like that doesn't matter, right? Like if the red plane was tilted out a little bit, you see what I mean? So that the shadow, so that the
That
intersection.
doesn't matter at that point.
Okay.
Because you're talking about where it intersects z=0.
Yes.
Well, the shadow, it doesn't matter with z.
Yeah.
Z doesn't matter at all, right? So, this is z=0, sorry.
Right.
That doesn't matter.
Right.
Right, because if you're tilting it out, right,
Right. So the shadow's bigger.
it's still
Yeah.
that when you look at the shadow, this part no longer matters. The z doesn't matter. You're just looking at the xy plane. So really, what you're looking at is z=0 is the xy plane, right?
Yeah.
You're looking at that projection,
Right.
which makes it even easier since it is z=0.
Yeah. Okay.
Yeah, so that doesn't matter if you tilt it like
Yeah.
this. Even if you tilt it this way, it's not going to matter.
Yeah. Okay.
It's not going to affect anything.
Okay. I'm just thinking about the relationship between the shadow
Or
and
I don't want to say it's not going to affect anything.
Right.
It will, but it's not going to affect how we do it.
right. Depending on it's still the same.
The process is
the
exactly
same
the same.
process. Cool. Thank you.
What was volume again? Set up as a triple integral.
The triple integral 1. The
Triple integral over what?
area of the shadow.
Just W.
Oh.
Right, you integrate over the solid that you want to find the volume of. So that is the integral, which means we have to describe the region, right? It's always good to have an idea of what you're setting up. And we are going to use triple integrals, right? We won't use double. Even though you'll see that it is going to wind up being the exact same thing. Copy. so glad I remembered this meeting. Because I just now got the alert for it. So let's look at our solids. There's only two of them, right? Z equals 2x squared plus y squared, and z equals 4 minus y squared. So what do we want to set as the viewing window? Tell you what I used. That's typically what I start with, and I just change it accordingly. Let's try and get a good sort of really kind of try and do this for now. Right, so what we're finding the volume of be that solid. So let's just try and make it a prettier picture. Really obvious. Start by finding bounds for z. Where is z going to go from?
2x squared plus y squared to 4 minus y squared.
This is where it gets. What do you want to define next, x or y?
Well, it doesn't really matter, does it? Or does it?
The shadow is going to be the curve of intersection. And so set your two z's equal to each other. And why is it like that when I do this? Curve of intersection is a circle.
We still have to find one in terms of the other, right? Yeah. But it doesn't matter which.
So do you want to do this vertically simple or horizontally simple?
Well, x goes from -2 to 2, and then y goes from
X goes from -2 to 2.
x. Oh, excuse me. X goes from square root of 2 to negative square root of 2, square root of 2. Y goes from negative square root.
And that's a circle of radius root 2, isn't it?
Yes.
So how do you want to define it? X first or Y? So vertically simple or horizontally simple?
Vertically simple with x as constants, right? Or is that horizontally simple?
That would be vertically.
Okay, yeah, vertically simple.
So what does Y go from?
Plus or minus the square root of. It goes from negative, sorry, it goes from negative the square root of 2 minus x squared to positive the square root of 2 minus x squared.
What about X?
X goes from negative square root of 2 to positive square root of 2.
There's your volume. Right, there's no Z, so it's just the length of that interval, which is what? 4 minus 2x squared minus 2y squared. How do you want to evaluate that?
From 0 to square root of 2 minus x squared, and then multiply that by 2. Or is that?
Good.
Not?
I'm not gonna do it.
you like set the lower bound to 0 and then check it back to 2 on that, so
Which lower bound?
I don't know.
You could do either of them, you could do both of them, it would be two.
Yeah.
You could.
So that would make it simpler.
Simpler, but not simplest. Remember, I thought I'm in the universe. Take the path of least resistance. Some of the things I learned in physics. Always be lazy.
You say work smarter for a reason.
Oh, and law of entropy. The room's going to become a mess anyway, so why bother expending energy to keep it clean? Especially when you have someone else who will do it for you.
We'll do the power rule with the last term and then the first two
I'm
terms.
missing something really obvious.
We group the first two terms.
Again, you could.
and- okay.
Huh? What do you mean read it out too? You can.
Are you talking about extending this from rectangular to polar?
Oh.
Isn't this a polar region?
Yes.
So be my guest, do it rectangular.
Looking at that, I'm just
How would you describe it in polar? So what would the outer limits be for theta?
Root 2. It's too high.
Inner limits, which are for R.
From 0 to 2.
What is it?
0 to 2.
I agree, 0.
0
Root 2.
Oh.
Radius is root 2. What does the integrand become?
4 minus 4 squared.
And what does dy dx become?
dr d theta.
R dr d theta. So I'm just going to multiply that R through. There is the new integral. Isn't that so much easier? In fact, one would dare say that is the path of least resistance. Because there's no theta. Actually, I'm almost going to factor out that too. Two R antiderivative is R squared, right? You value R squared from 0 to 2, what do you get? I'm sorry, you're right. But I meant 0 to root 2. I said 0 to 0. It should be 0 to root 2.
Right.
Antiderivative of R cubed.
Quarter R to 4.
Or R to the fourth. R to the fourth from 0 to root 2.
Well, oh. So 4.
Times a quarter.
Yeah, 4.
The volume. 4 pi. Which means, by the way, if you were to try to do it in rectangular, there'd be tricks up and balls. That's the only way you would get a fourth, you'd get a pi out of it, is if there's tricks up. I guess that's not actually true. If you get 1 over something, you get an inverse. trig function out of the antiderivative. But you're not going to get a 1 over here, I don't believe. So this is going to involve trig sub, which is a pain in the ass. So. See how quickly we forgot polar? That's very sad. Okay, now drown. And now it's the easy problem. We found your corpse. The autopsy isn't too difficult. There are boulders tied to your legs and a bunch of hungry sharks with laser beams attached to their heads in the pool. And cause of passing is pretty obvious.
Now it was a suicide.
Clear. Suicide by knife to the back. Weird things have happened. What was the average value?
Triple integral divided by area. Volume. I was thinking volume. I said area.
What is the volume? What order do you want to do?
Z first.
Then what?
Then X and Y. Then my choice of X and Y was arbitrary. Is there a better way if you? It doesn't matter, right?
It doesn't, but one is going to be easier than another. Right? Yeah, one's going to be easier than the other. If you do Y, you're actually going to have to do integration by parts.
Oh, okay. Yeah, but if you do X.
If you do X before Y, you might be able to avoid integration by
I see.
parts.
I see that.
I say might be able to. Doesn't guarantee you will. But we might get lucky. Oh, well, Z is easy. Integrate that with respect to Z, what do you get?
2.
Now with respect to X. Antiderivative would just be negative e to the negative xy. Evaluate that from x equals 0 to 2. E to the negative 2y minus e to the 0, right? Oh, no integration by parts. What's the partial derivative of negative xy with respect to x? Yeah, y up front. That's essentially change of variable.
Oh, I see.
Oh, now this is simple, right? Negative a half, e to the negative 2y minus y, from 0 to 3. We have what? Negative 6 times. I'm not going to factor out that negative 1 now. E to the minus 6 minus e to the 0. Then minus 6. Is that right? No, plus. So factor out a negative. Right. Yeah, that's right. Five plus e to the minus 6 all over 12, and if you don't like negative exponents, 5e to the 6th plus 1 all over 12e to the 6th. Who's that? That was nice. Ended on a nice problem. This is like we just performed CPR and we resuscitated, we go back to life. Problem is you still have sharks with laser except with heads gnawing at you because they came out wicked.
Used to that by now.
Questions on triple integral? It's nothing different, right? It's just an added step. By the way, when we took this double integral of a function, what were we finding?
Area.
Double integral of a function. What is it? Close. Sine volume. So what do you think a triple integral represents?
Sine hypervolume?
A sine hypervolume, which is the fourth dimensional equivalent measure, right? You have length, which is first dimension, area is 2 dimension, volume is 3, hypervolume is 4. So if you did a 4-level integral, you'd be finding the 5th dimensional equivalent. Hypervolume? I don't know what they call it. Luckily, we don't go up that high. And so what we're doing when we're evaluating a triple integral is actually finding a signed hypervolume geometrically. Why don't we mention it? Because we are just simple 3-dimensional beings. We cannot possibly imagine what the 4th dimension is like. But that is what we're doing. So apparently there was a project that somehow slipped past me. We're supposed to be due what? 7th?
Yesterday.
Oh, that's right. We're supposed to be due the 4th. Make no sense because we don't meet on a Monday. So I don't know why it was set to be due there. I think I just has a placeholder and just forgot to.
I thought it was originally set to the 5th, and then my group contacted.
That would make more sense.
The 4th. Doesn't make
Yeah,
any sense.
so I think there was a placeholder and I just forgot to change things.
I didn't really question it.
That's probably what I did. So homework 16 is tentatively due the 7th. was supposed to be covered last Thursday. I am open to changing that if need be. So try and get it done, but don't stress yourself out.
Is homework 16 what was done today?
Yeah,
Yeah, it's triple integrals.
is that on the exam?
Yes. Which is why I'm trying to get it done by the 7th, because it is going to be covered on the exam. But don't stress yourself out over it, because I am open to extending that. Since we did it today, so I'm open to extending it to next Tuesday. Project 3 for right now. Let's aim for next week, but again, I am very open to extend that another week. The problem is, Project 4 goes live next week. So it's a matter of then, do you want to have 2 projects that you're working on at once, or just one? So that's why I said aim to have it done by the 12th. But don't stress, again, don't stress yourself out. I'm open to extending that. There's a bonus up there for exam 2 that is due before the exam. Again, it gives you a chance to earn an extra 10%, 10 points. And exam 2 is next class. Exam 2 covers. What did exam 1 end with? Was that, did exam 1 cover motion in space or no?
Some, yeah, it had
Yeah.
So it did all of vectors?
Yeah.
yeah,
Then exam 2 would start with the multivariate functions and go up through triple integrals. What we just did tonight. It will not cover cylindrical and spherical triple integrals, because that we're going to do next week.
But it will develop, okay.
It covers polar and double. It covers everything that we did double.
Is it open notes like the last exam?
Yes. However, I would recommend you study.
How many questions do you think you do?
That number. I think it's fewer than last time, but that's because the RNG got really loved multiple integration for some reason, because most of the questions I was getting was multiple integration questions. I had to actually force it to give me multivariate function types of problems. So yeah, there's a lot of multiple integration on there. So be advised of that.
and there will be some questions where there's a distinction between like setting it up, in which case you can use the calculator, and
So yeah,
yeah,
you will be allowed to evaluate integrals with a calculator unless the problem tells you you're not allowed to.
right, explicitly.
There are a few problems that I did say no calculator.
Okay.
For the integrals, you can use the calculator to do like multiplication or things like that, but you cannot use it to actually evaluate the integral. You have to do it right. Which means, generally speaking, those are either simple integrals or integrals that involve a special technique to make it simple that I want to see if you know. You don't have to do any really difficult integrals by hand. So if the integral looks difficult, there's probably a trick to make it simple. Like, where was it? Like this one, for instance. There might also be problems on there where I ask you to set up the integral but not to evaluate it. And so obviously make sure you read the question and answer what is being asked. Don't do more than you have to. And you want to study, do not just rely on your notes. The first exam should be an indication of that. You also want to do that so that you're not spending a lot of time flipping through your notes. Right, so it might even be better just to write up a sheet of formulas that you have quick access to. That way you're only going to flip through your notes if you absolutely need to. And the exam is on two fronts, testing your knowledge and testing your time management. Figure 1 point per minute. Right, it's a 100-minute exam, 100 points. So if it's a 15-point problem, you should expect to spend like 15 minutes on it. If it's a 2-point problem, if you're taking more than you're probably doing it wrong. what you know first. Don't stress out over a problem. If you're stuck, move on and come back to it later.
Would it be really bad form to, like, as long as they're clearly numbered, do,
Out of order?
yeah, in the book? All right,
If
okay.
you just clearly number them.
Clearly, right.
I can find it.
Right, okay, thank you.
Because that's what I do have some who do that, and I go flip through the book.
Okay,
Just don't do something like, you know, you ended on, let's say, page 4, and then you did a problem on page 15.
right.
So I'm not going to flip through every single page. If I see a blank page, I'm going to assume that you're done. And so make sure that you actually do go, in terms of pages that you're using sequential order of pages. You're not skipping pages. But other than that, yeah, you can do the problem in any order you want. Just clearly label it.
Okay, cool, that'd be very helpful, thank you.
Don't stress over it.
I think you do the last test, kind of,
Yeah, don't stress over it. If you come in stressed, you're already screwed.
yeah, that was my downfall.
If you come in with the attitude of, I'm not going to pass this, well, you just fulfilled it. Because you're not going to pass it if you come with that attitude. But you've already set yourself up for failure, you're going to fail. Right? You know the material. You have all the tools. There's nothing on there that you can't do. There is generally 1 or 2 questions I always put on to test how well you know it. It will not be anything like what we've seen in class, but you still have the tools to do it. Right? I don't just give you an A for copying what I do. An A means you've mastered it, so you're going to be able to take what we did in class and apply it to a new situation. And again, remember, let's see you Thursday.
Want to grab a table out there? Yeah.